Good morning. This is Govardhan. So today let's discuss about congestion control. So first of all, what is a congestion? So congestion is an important issue that can arise in packet switched network. Congestion is a situation in communication networks in which too many packets are present in a part of subnet, and it immediately degrades the performance of the network. So congestion in a network may occur when the load on the network is greater than the capacity of the network. That is, the number of packets sent to the network is greater than the number of packets a network can handle. Next, the various factors that cause the congestion are: the first thing is the input traffic rate exceeds the capacity of the output line. So whenever the capacity of the output line is less than the input traffic rate, then it immediately there is a chance of occurring congestion. And the second one is insufficient memory to hold arriving packets. So if the buffer space is less than the incoming packets, then it also leads to congestion. The third one is bursty nature of traffic. If suddenly a stream of packets enter into network and a subnet cannot handle this stream of packets, so that congestion builds upon. And next one is slow processor. Congestion occurs if the processors are slow. Slow processors at routers will perform the routine tasks such as queuing the buffers, updating tables, etc. slowly. As a result of this, queues are built up even though there is excess line capacity. And the last one is slow links. Congestion also caused by slow links. And next, the congestion control versus flow control. So both terms seems the same, but there is a slight difference between congestion control and flow control. Now we will see the difference between congestion control and flow control. Congestion control is a global issue which involves every router and host within the subnet. And coming to the flow control, its scope is only point to point, that is from sender to receive, one sender and one receiver. But in the case of congestion control, it is a global issue. It involves many number of senders and receivers. And then now we will see the how to control the congestion. Congestion control is concerned with efficiently using network at a very high load. So several techniques can be employed to control the congestion. The first one is warning bit and choke packets and load setting, random early discord, and traffic shaping. The first three, warning bit, choke packets, and load setting, these three deals with the congestion detection methods and recovery techniques. And the last two, random early discord and traffic shaping, these two deals with congestion avoidance. And now we will see warning bit. A special bit in the packet header is set by the router to warn the source when congestion is detected. So whenever there is a chance of occurring congestion, then immediately that is detected by the host, and a single bit is copied into the piggybacked acknowledgement and send it back to the sender. And the sender monitors the total number of acknowledgement packets that receives with the warning bit set and adjusts its transmission rate accordingly. So the sender knows if it receives acknowledgement packet, then it knows that so there is a chance of occurring congestion in the network, so it slows down its transmission rate immediately. And the second technique is choke packets, a more direct way of telling the source to slow down. So from directly from the node on which the congestion is likely to be occurred, that will directly inform to the source to slow down the transmission rate. An example of this choke packet is the ICMP source quench packet. And third one is hop by hop choke packets. Over long distances or at high speed networks, the choke packets are not very efficient method. So the more efficient method in the high speed networks or over a long distances, the choke packets, hop by hop choke packets is the correct method. So this requires each hop to reduce its transmission even before the choke packet arrives at the source. And the next method is load shedding. When buffers become full, routers simply discard the packets. Here the important thing is whenever buffer becomes full, then immediately it will discard the packets. But here the router has to take the decision which packets are discarded from the queue. So which packet is chosen to be the victim depends on the application and on the error strategy used in the data link layer. Suppose for a file transfer, they cannot discard the older packets since these older packets will cause a gap in the received data. So in the case of file transfer application, so it is better to discard older packets. And in the case of real-time voice or video, it is better way to discard old data and keep the new packets. Okay. And next one is random early discard. So this is a dynamic approach in which the router discards one or more packets before the buffer becomes completely full. So each time a packet arrives, the RED method computes the average queue length. That value is average. So if the average queue length is lower than some threshold value, that lower so there are two threshold values. The first one is lower threshold value and maximum threshold value. If the average value is less than the lower threshold value, then congestion is assumed to be minimal in that particular node or non-existent, and that packet is queued into the queue. If the average value is greater than the upper threshold value, then congestion is assumed to be very serious and the packet is discarded immediately. And if the average queue length is between the minimum threshold value and upper threshold value, it is in between, then the probability of congestion is then immediately calculated. And the traffic shaping methods. So another method of congestion control is to shape the traffic before it enters into the network. So in beforehand, we need to shape the traffic or incoming packets by using these traffic shaping methods. Traffic shaping controls the rate at which packets are sent. Okay. At connection setup time, the sender and carrier negotiate a traffic pattern. So first decides to which traffic shaping method we need to follow. So there are two traffic shaping algorithms are there, leaky bucket and token bucket. So now we will see in detail the leaky bucket algorithm. In the leaky bucket algorithm, it is used to control the rate in a network, and it is implemented as a single server queue with constant service time. If the bucket overflows, that is the queue is full, then packets are discarded. So here, so whenever the incoming packets or this buffer is full, then it will discard the packets constantly at constant speed. So these are the main points of leaky bucket algorithm. The leaky bucket enforces a constant output rate regardless of the burstiness of the input. It does nothing when input is idle. If there are no packets in the queue, then it does nothing. And the host injects one packet per clock tick onto the network. This results in a uniform flow of packets, smoothing out bursts and reducing congestion. So this is leaky bucket algorithm. And coming to token bucket algorithm, in contrast to the leaky bucket algorithm, the token bucket algorithm allows the output rate to vary depending on the size of the burst. In the token bucket algorithm, the bucket holds tokens to transmit a packet. So to transmit a packet, it consumes one token. Okay. So tokens are generated by a clock at a rate of one token for every delta t seconds. Ideal host can capture. So if there are no packets to transmit, then it will capture the tokens and it will save the tokens for sending the larger bursts later. So here these are the incoming packets. So it is the buffer space, and here for every delta t seconds there will be a one packet is generated, that is token is generated, and for every packet sends out of this buffer consumes one particular token. So leaky bucket discards. So now we will see the difference between leaky bucket algorithm and token bucket algorithm. So in leaky bucket it discards the packets, but token bucket it doesn't discard the packets. It discards the tokens. For every packet it will discard one token or it consumes one token. With token bucket, a packet can only be transmitted if there are enough tokens to cover its length in bytes. And in the leaky bucket sends packets at an average rate or at a constant rate. Token bucket allows for large bursts to be sent faster by speeding up the output. Token bucket allows saving up tokens to send large bursts. So this leaky bucket does not allow savings. Thank you.